welcome to my talk with the title Building a Cloud-Native Healthcare Data Integration with Dapper. That's quite a blocky name, so let's start with this and let's hold on for a second and look into the title, what it's mean, what are the parts are of it. And in the middle, Healthcare Data Integrator is a big step or part, so let's have a look at what healthcare data is anyway. I personally like that very much when I go to conference talks or watch them on YouTube to learn a little bit more than just the generic tech stuff and to some steps into domain knowledge every now and then. And I offer you a quick detour now on healthcare data. After 10 minutes or so, we head into the more generic stuff. So let's start with that. So in the very beginning, healthcare practitioners have numerous reasons to exchange data, right? Classically or historically, one of the first things usually happens is exchanging financial data and billing information because that's how our public healthcare infrastructure usually is built, like cash flow is important. Following organizational information is also important to actually manage the daily workflow, like making appointments, booking rooms, allocating resources like expensive equipment and so on. But I believe that the most potential for improving the clinical aspects of healthcare lies within the clinical data itself. So clinical data is the actual data about, for instance, a clinical concept like blood pressure. So you have the systolic value or the diastolic value and so on. If you utilize that to make treatments, diagnoses, and so on, you are doing primary work with it. That's the lowest point here on the button, that there are two general senses of how you can utilize clinical data. In the primary case, you make direct clinical work with it. In the secondary case, you use that data, especially in places like university hospitals, where you have a lot of daily clinical primary data, and utilize this to do something like research on top of it. I mean, there are obviously things like privacy and so on included in this mix, but we are only looking at the healthcare data stuff right now. So we figured out that clinical data is important, and we want to improve healthcare, so we get the clinical data, do some magic, and then easy, better healthcare. Of course, that's not that easy. It never is. And now it gets complex. When I talk about complexity here, it means my personal view on those topics, right? I'm a professional in this sector and this domain, and this is very complex for me because I understand it, and there are other very complex topics out there as well, of course. So to do a little assessment of what we usually have, we have tons of legacy systems. Hospitals are generally very old, and GP practitioners or other sorts of clinics are at least somewhat old in the most cases as well. And they are not compatible with each other by definition, or they are not meant to talk to each other from like the original design. Inside of those systems, we have sometimes even older data. In hospitals that have maybe 30-year-old data, and on top a modern system that got modernized like 5 years ago or something, doesn't help because the data is also not very compatible by design to other data sets. In-house and in clinics and so on, it's more or less handled nowadays, but when you're talking with other clinics, that gets complicated very quickly. So we have the need of interoperability, right? That's something not only in the healthcare sector on vogue, you might say, it's also in messaging and so on right now. And interoperability can have different definitions, of course, but this is a simplified ladder. On the first level, on the technical level, you make components speak with each other in a sense that you might say they have like a TCP/IP connection and can ping and actually push things or something like that. On the next level, you agree on the synthetics. That means you have an agreement on like the payload. Let's just say for simplicity something like JSON with like a list of attributes or something. But the actual benefit comes in when you carry semantics. That means the clinical concepts can actually be understood in the same way on the source system and the target system. That enables the secondary usage I was talking about. That makes clinical research on top of this data possible. And then you can always go higher. Okay, but now we have different things targeting different of those levels, but as it turns out, it's always a bit more complex. They aren't compatible with each other by design as well. And anyway, they are very important and common, and I will show you two of them. The one thing is called OpenEHR, or OpenAir sometimes. EHR is for electronic health record. And it's a framework utilizing different things on a technical level to reach like the first steps, and then covers some things on the modeling or clinical level, and covers the semantic level with that. I won't go into detail here, but it utilizes different architectural things and properties to actually tackle this semantic level you just saw in this diagram. A fun fact here, while we are in Barcelona, and this is the region of Catalonia, the local healthcare authority currently is in the process of shifting its public healthcare infrastructure over to OpenEHR systems. And they're very eager to have more technical people having knowledge about those things, because this will be getting more and more important all over Europe. Another very common and widely used standard is FHIR. FHIR is meant for healthcare data exchange. In result, it has a very good and technical and lean foundation to actually commence those technical interoperability steps up to the semantic level, and leaks a little bit into the semantic world, because it gives you also resources and things you can use to cover some clinical things. Well, in theory, that's it. But of course, there is always more. There are tons of more standards, and then the reality comes in. And this was the meme from the beginning. This is a meme from a dear colleague of mine in this healthcare data space, Birger Habrand, who captured here that we, as maybe the bit boring left guy types, sitting there on our desktops and writing great, I hope so, healthcare specifications, and then the reality comes in and gives us different data and things than we anticipated. So before it gets too crazy, we'll just draw a line here and then head over to the more general part. So a little slide about me. As you figured by now probably is that I'm a health informatician specialist and software engineer. I've been working in this space for over 5 years now. I'm particularly active in this OpenEHR world and an active community member over there. One of the biggest projects I've been working on is called Airbase. Airbase is an open source implementation of OpenEHR. You can check that out on GitHub. It's also Spring-based and Spring Boot and so on. Now at Better, I'm working on a project to bring those worlds of those two standards I just showed you closer together, right? So that's what we call it FHIR Connect. And this is my very first conference talk, so I'm very glad to be here. Okay, over this more generic part here, I will take you on this journey of this product, right? I will use this map, the simplified map, to go over 3 steps with you. The first one is figuring out what we want to do, how we want to do it on paper, then implementing the prototype. Then figuring out that's just a prototype, right? So we gotta make it a good, real implementation and product. So the next step is like a microservice architecture, then also figuring out that might not be ideal. I'll show you why then, and why Dapper might be a good solution to get a lot of those things covered. Then I will introduce you to Dapper, give you a quick demo, and finally show you how this works in this product and project. So at first we have the idea. So what's the project? In essence, this is a bit like a placeholder if you want to, but in general, you got to figure out what you want, right? So we have the need for a mapper. We have those different standards with different data representations. We want to bring them together. We want to leverage different properties of those things and have a bidirectionally bidirectionally mapping, and so on. But this is like a placeholder if you want. And finally, we reach some sort of on-paper implementation, like how this should work, right? In our case, and this is also a little bit like a placeholder if you don't want to get into the healthcare stuff, but otherwise this will come up in a second again. We have the idea to have like a model library, which is globally shared, community-driven, where you map the smallest parts of information in its clinical sense, for instance, the blood pressure or body height between these two standards, and then you can leverage them and use them in a reusable sense without changing them. So in one instance, you could build an application that handles medication and take both of those things to calculate maybe dosages or something like that. But then you can reuse one of those to build like a growth chart, maybe tracking the height and development of a baby or something like that. In essence, that only means that we have an on-paper plan, and we know how this works, right? And again, this this covers the summary of what we are going to do on paper, and we draw a line here on the healthcare stuff right now. If you want to know more, of course, get in touch with me. I'm very passionate about it, so if you want to talk, that's very welcome. Okay, now we want to build that. That means going into architecture, figuring out what we want to do. So we have the need, we have the idea, we have the general concept, so we need the solution, right? That means first step, first stage, or whatever. So a simple concept might be something like that. When you have an architecture with the core, okay, that name is taken here, with the main component called Fire Connect here, and inside of it is the core that actually handles like this transformation. It depends on the different modeling definitions, and by so also on the community because they are building it. And then on top we have a pluggable component that utilizes the data capabilities, or the core capabilities, to transfer the different things, and then systems connecting to it, right? It's fairly simple. It's the architecture to make the concept work. Nothing more, but enough to do that. Almost by chance, or maybe that's the reason why you do such things, right? We figure out that there is some kind of separation happening already. We have at least 2, and depending on how you implement it, 4 components inside of this Fire Connect. That's something worth seeing. Making this work, I did what probably most of you would do here: take Spring Boot, do some, pull in whatever you need else to do the job. In my case, I like to do it in Kotlin and then use Apache Camel, because Apache Camel is an integration framework, and I did a lot of integrational work. So that's a good choice here, I think. But in any way, what's happening is prototyping, right? That means I'm making it work, nothing else for now. And probably there are better methods of doing that, right? But I think that's very realistic to approach it that way. In essence, that means I'm not actually covering any of those conceptual components, any of those components and their behavior and their connection. I'm just having one monolithic, well, it's small, but technically it's monolithic application that does what I want. I cover some behavioral things with unit tests, but that, of course, is only inside, as per definition of unit tests, and only to some extent manually or automated maybe API testings to show that it does what I want. So I have the sole focus on logic. Therefore, as a result, I'm satisfying the requirements, which is what I want, which is great, but then again, not maybe the best foundation for the future-proof and great product in general. Especially, in my experience, once you do that, the next questions are always around the corner. So I showed that the concept worked, and without any delay, superiors and other people are coming up and asking all those questions, right? Like, does it even scale, or how you actually glue these components together? Is it future-proof? What are all the cool new trends you want to utilize? And what about the customers, right? That's always very important. Don't forget about that. In essence, that boils down to having strategies for all those things, right? So we want to achieve scaling, cloud-native deployment, and in our case, as a software vendor, being agnostic as possible. That means customers should be able to deploy those things as much as they prefer in regards of their architectural choices and actual platforms and infrastructure. Okay, now I said cloud native. I don't want to go in detail here, of course, and actually almost don't want to talk about it at all, but I mentioned one thing because I like it very much, and just in case you didn't know that, is the 12-factor app methodology, which is like a set of learnings if you want to build software as a service applications or cloud native applications, whatever you might call them, distributed applications. And this is a great source for knowledge in that case. For instance, the number 3 of those rules says that you shall store the deployment configuration in the environment, so it's portable, right? You have, especially in container environments, a portable approach of only the configuration changes between the deployments, or that the application should be stateless and only use state stores to manage its state, so you can restart the application without, it's independent of restarts, and you don't carry assumptions over the requests. That's very important, right? But in essence, this is last updated 2017, and as per definition of knowledge, I would say it's valid until proven otherwise, right? But tech is moving fast, so just keep that in mind when looking at it. I think it's still a very great resource. And yeah, now we have the rules. This is like the illustration of the knowledge we need, right? There's of course more. But it's still not easy, because now we would be in a situation where we actually have to implement at least 12 somewhat big pieces of knowledge in this, or embed this learnings into our application, but of course even more. And this gets very complicated, right? So we also have to think of different services, platforms, infrastructure, and all those things, and build that inside of our application. So there got to be something in regards of real-world tech that helps us here, right? And we wouldn't be here if there wouldn't be Spring to help us with those things. And there's Spring Cloud, right? And I think it's a great resource and a very good thing to start your endeavor in this direction, because it has a lot of resources, right? It has a lot of components that cover a lot of ground. So you can have all those, I call it glue between microservice architectures, which means configuration, discovery, load balancing, and so on. And also has some abstractions to make you more independent. But it is also limited in the sense that at its foundation, it's still a JVM framework, a sub-project of a JVM framework, but you know what I mean. And it's not possible with Spring Cloud components to 100% control the infrastructure independent of the applications, or deploy it in a, I mean, there are probably ways, but it's not very easy and a straightforward choice if you want to deploy it in a mixed architecture where you have different kind of apps from different frameworks or languages. It gets just complicated. As a result, we have with Spring Cloud a lot of control about all those things, again, like also discovery and load balancing and all those things, but it also means we have a lot of responsibility. And it is not 100% agnostic. When you look at, for instance, Spring Cloud streaming and you want to utilize Apache Kafka or RabbitMQ or something, you have to utilize the specific binder implementation and then pull some, it's not that much, but some dependency into your applications. And it's not the so right answer in a mixed setup. I already hinted at that. That means if you have different languages and frameworks, just a little bit out of scope, you know, to Spring Cloud can't just propagate its idea to these realms. In any way, the next step of this journey is next evolution maybe, or step in the development of this application where I utilize Spring Cloud technology. And there's a lot going on suddenly. We have a Spring Cloud technology with microservice-like designs, matching queue, several topics, several servers, function-like scaling with different components, and just verbally you see that or hear that there's a lot of stuff going on. And I will have an internal diagram now on the next slide. Internal, it's like a rough internal step. It's not beautified for presentation. So a quick diagram horror show here. Okay, it's not that bad maybe, right? But again, the arrows and everything is not aligned. So this is just for the message. And it got out of hand very quickly. This is not even covering all those glue things like discovery, resiliency, distributed configuration, and all those things. Just managed to cover like the general implementation of the concept, right? And personally, I came across this threshold where I was suddenly spending most of my time figuring out how those components are working. As I was fairly new to this general scope, I was figuring out what even Kafka is, what are the Kafka concepts, how can I use that in Spring Cloud, how are the limitations and possibilities in Spring Cloud, and then finally how I can pull that into my application. So at some point I was asking myself if I am still writing logic for my exciting new project, or am I already maintaining infrastructure? And to some extent I was. So the limitations here are by inheritance. When using Spring Cloud, you kind of inherit those limitations, right? In many cases, that's probably very okay and also great. Sorry, it's great to use Spring Cloud, especially if you have like, I don't know, 500 people internal development and everyone uses Spring for every application and service, then it's really good choice, I guess. But you got to consider those limitations. And I have suddenly the need to handle all those glue things, right? And I spend less and less time writing direct value or creating direct value, which would be my job, essentially. So there's got to be something better. And I went on researching. I just previously said, like a minute ago or so, that I was kind of new to this whole topic, so there was a lot to discover, and the research was very interesting, many technologies, many things to learn. But one thing that stood out for me, and it was Dapper. And I want to show you how this works and what it is. The Distributed Application Runtime. So to do that, I will go into the official open presentation, because it's very good and there's just no need. Oh, that's interesting. Sorry. To recreate it, if it's good already, and it's an openly governed and open source project anyway, and they encourage you to use this presentation, right? So I'm good here, I hope. No, they know I'm holding this, giving this talk here and everything. So Dapr, the distributed application runtime. Their idea is that we are currently in the state that enterprise devs are suddenly need or asked to handle a lot of things, right? I tried to illustrate this in the steps before. Suddenly, I'm not able to write the logic anymore. Only I have to do a lot of different things at once. I personally feel the center point at most, but other things apply as well. So in a general sense, we used to the classical way of tackling business problems. That means implementing actual classical software, databases, web apps, all those things. But suddenly it's very more complicated, and we have the need to use a vast majority of SDKs. I mean, with Spring Cloud, we are lucky and don't have the need to do it in a rough way if you would do it in a bare Java application. But still, it gets very complicated. And also, we have the need to deploy those things more agnostically between different cloud providers or different architectures, in a sense that on-premise or even in Kubernetes and all those things are very important today. So usually you build something like that, right? It's just an illustration again of a simple or realistic, maybe, I don't know, microservice architecture. The point is we have a different, not just two, but an okay amount or a relevant amount of services who are talking with each other, have different dependencies inside and outside, right? So why is that so complicated? I pointed that out a little bit earlier, that we have tools and we can use those things to help us, but they are always limited to some extent. I mean, Dapper isn't crazy super magic in the end as well, but it helps you to tackle a lot of those things. So we have the ability to go over those limitations in regard of different tech stacks, infrastructure, and so on, and have implicit glue, as I would call it. I will show you in a second. So Dapper then came up at some point. It was originally a Microsoft project, but is now part of the Cloud Native Computing Foundation and is open source, openly governed, and so on. And their goals were to establish best practices in building blocks, which you then can utilize in your service architecture. Those building blocks are the core. They represent the function sets and also take off the bunch of mundane tasks from the applications itself. They are communicating with an open API inside of this Dapper system, and they are extensible, pluggable components. This will be important in this following journey as well. So in essence, you are able to write applications in any language or framework, and it's community-driven and so on. You can deploy it on any infrastructure. So to show you the general overview here, this is a very good intro slide, I think, to this technical stuff on Dapper. The building blocks and the general Dapper scope are in the center. You can see a subset or maybe the full set of building blocks right here. That means you have typical things covered. That means state management, publish and subscribe stuff, service-to-service invocation, and so on. And because this is pluggable and connected through its open API, you can basically attach any kind of application on top of it because it only has to speak a rather simple API and don't know any about the concepts that lies between these two edges of the Dapper scope. Those building blocks essentially can be instantiated with different components. That means different tech implementations. So for instance, a publish and subscribe building block can be utilized with a Rabbit, MQ, Kafka, and so on, while not changing how it communicates with the application. And then this whole blob can be deployed on any infrastructure. Together, this whole setup takes a huge burden from the application, right? So how does that work? They utilize a model they call, or is called, I don't know, sidecar model. So you have your application, and you want to hook it into this Dapper system, right? So you could write things inside of this application, but then you would just blow it up again, and you want to detach things, right? Make it easier for the application to be an independent, small as possible application. So you have a separate process, a Dapper sidecar, which is attached to your application with this very simple API. You have SDKs out there to do that, or you can just manually do those requests in either HTTP or gRPC, and do kind of simple things like posting a request to invoke a certain service, getting a specific state, posting a message to the queue or pub/sub queue, or getting a secret. And everything else is handled from the Dapper sidecar on into the Dapper world. That means no SDKs, no credentials, no retries, and so on. And in essence, we have this set of APIs, which equals the functionality sets, the building blocks. I showed some of them, so I will not go all over here again, but we have the ability to publish into a queue, subscribe to this queue, invoke different services, even have the ability to trigger things from the outside. That means like an Azure Event Hub or something, whatever. There are different components available, but also trigger things on the outside from this Dapper application, and so on. To see what is possible in terms of actual technical or tech stacks, here's a summary or a short overview of those things, and there are way more officially available, but this is a great subset, I think. Yeah, as I said, for instance, in those pub/sub brokers, you can just switch between different on-prem hosting things you would usually use maybe in a dev environment, let's say a Redis client server, and also in deployment, then you could just switch to an AWS-hosted SQS, for instance, and the application won't change. You don't need to change how it talks to this Dapper sidecar. In essence, that has the result that we could have a simple setup like this, 3-component. They have different kind of connections, like in the middle is a RabbitMQ pub/sub queue thing. Then we have a Redis state store and a HashiCorp vault for handling secrets. And then this could be hosted on-premise. Without changing any of those services, like the logic and how it communicates with each other, we can configure it to be deployed on AWS or on Azure or anything else that is supported. And that's very easy. Here's another overview of those building blocks, and you can just read for a second while I drink. Okay, the basics are now covered, and we will head on into a personal selection of other features that are implicitly included in Dapper, right? So, for instance, we have observability. That's something with Spring Cloud you would need to have to configure at least and implement to some extent. And in this Dapper setup, you have already included Open Telemetry Collector, which you then can utilize with different logging or tracing capabilities to finally do something like distributed tracing, right? And that's, I will show you this in the demo in a second. This is implicitly working. You can configure all those things, of course, but the basics are there. The same goes with metrics. So for general health and overview, and those things are collected and made available for you. We have baked in resiliency. That depends on each API a little bit because they're semantically different, but in general, you have things like retries, timeouts, circuit breakers, and so on. Again, this can be configured, but the general, like best practice things are already running. In one example, the pub/sub situation, for instance, timeout is handled in an agnostic way that Redis and Kafka, for instance, have different meanings or implementations of timeout, right? And Dapper has then, on top of it, it's abstracted or abstract timeout itself. So the messaging queue could actually hold like 100 messages or so, and then the sidecar evaluates if this is still valid ones or not, and then only push those things into the processor here on the right if it's valid. That makes you independent of the actual implementation. Okay, to round that up, we have different hosting environments. I said that, I don't know, 100 times already. You can basically deploy that anywhere. And to have a look, oh, and it's not on the slide, I think, but you can also host it without Docker. If you manually, natively run a Redis or something on your machine, then you, of course, connect it to those as well. It doesn't need to be containerized. But it can be up to some things like Kubernetes, right? To have a look into the technical stuff that happens, just for the little bit of insight here. In a self-hosted Docker mode, which is essentially the thing you would do on your local machine to develop Dapper applications, or put your, for instance, Spring Boot application inside of the Dapper setup or architecture, you would download the Dapper CLI tool, run Dapper init, and then you get 3 helper containers to get you running. Then you run your application with this. This is like like a development helping thing. To launch your application, launch the sidecar process and couple them, as in configure them to talk to each other. So over the sidecar, your app is now enabled to talk to all the different components here that are already there, and all the ones you're going to configure as well. On Kubernetes, this is kind of the same, but technically, of course, different. Your application is in one pod, then you get like a layer of helping service pods from Dapper, and they handle all the things like the internal MTLS encryption and discovery and all those things, but also, and very importantly, the injection of the sidecar into your app's pod. So finally, this application is then again, like before, enabled to talk to all the different components. Okay, this is the intro part here on Dapper. And yeah, if you have more interest in it, on a more formal sense, please check out the website. It is a very good documentation. It has a very good documentation, and head over for the community because it's very friendly and helpful. Okay, now I show you a quick demo. I will utilize one of those things they offer you to get started, namely the quick starts. The quick starts are a very lean and cool way to get started, to get to know it, and a great resource for reliable live demos, so I don't screw up here. And essentially what you need is what I already mentioned. On the right side you see initializing the environment, and it basically puts those containers into your Docker environment, configures some things, and then you're almost good to go. This is, sorry. This is one of the quick starts. And this is a publish and subscribe example. You have different quick starts available. They are just switched over to doing those very extensive quick starts, so they are still working on other examples here to cover all the ground. You're still always able to go to the older tutorials, the way I learned it, and there are more things covered. And anyway, we are going to look at the publish and subscribe quick start. And this covers a very simple architecture here, right? So we have a checkout application which creates orders and push them into, from the point of view of the application, an agnostic queue. On the other side, we have an order processor which waits for messages in the specific topic and then processes them. As easy as it gets, right? So again, as it's very important for Dapper to have the ability to utilize different languages and framework, we have always different tutorial examples going on, but we of course want to go into Java. Then you can clone the repo, maybe clean install it, and so on, and run it. I will show you the running in a second. What's more important right now is this one here. Basically, this application is a plain Spring Boot application with a simple REST controller. As plain as it's only adding this additional annotation here. This is from the Dapper Java SDK and helps you to hook your REST controller into this sidecar, or technically speaking, you register this REST endpoint in the sidecar, and once the sidecar figures out there is a message, it will post it to this endpoint, right? But this means you can leverage all the other Spring Boot things and everything else because it's hooked into this ecosystem. In terms of configuration, you just say, I want to have all the messages from the topic name orders in this component with that name. Other than that, the payload is wrapped inside a cloud event. This is something your normal plain app maybe wouldn't have, but this is Dapper's way of adapting standards because this helps out. Okay, on the other side, to utilize those things, you have a helper, which is the Dapper client, and you can basically push, again with the same configuration, the pub subtopic name of the component and the topic, and then the payload. To run that, I hope this terminal is big enough, the font. Let's start with this one. So in essence, you run your application that gets the messages with a port binding, so the sidecar knows to which endpoint it actually has to push those things, right? And then give it the component path. I'll show that in a second, what that means, how to configure the actual queuing thing inside of it, and then basically run the application, right? And everything else will happen. So the sidecar starts and hooks into like the Java process. No, it's not really hooking into, but it's starting it and then communicating with it. Right now then, it's the next step, it of course waits, right? Because there's no information there. And on the other side, I don't need that port because my application pushes to the Dapper sidecar, and it's the other way around. So the sidecar starts, and then we publish the first piece of data, and I wait for the second one, and then on the other side you can see they got received, right? To have more info on that, you can always head into the directly included zipkin for the tracing and just look into the different messages. So you can see the different applications talking with each other and how long that took and all the different things you configured in terms of telemetry. To actually configure this queue in this demo, you need this component, and then we have it all covered. So that's fairly simple, right? This is like a Kubernetes-inspired YAML, and it defines a component with a unique identifying name, then specifies the actual technical connection, and gives it a scope, what kind of components on the other side are allowed to connect to it. And that's it. I think that's fairly simple and easy to use. Okay. So for the Java SDK, you saw already that there are different SDKs and they have not, in essence, I think, practically speaking, they have different capabilities, right? But they all cover the general feature set. We have this high abstraction of Dapper with the different building blocks, so we can utilize that very easy with and within the SDKs, right? On top of that, here for the Java SDK, we have somewhat of an integration into Spring Boot. As I just mentioned, we have, for instance, this annotation, but we also have some more things in regards of actors. But I didn't cover actors at all. For now, that would be somewhat a little advanced topic. Okay, now we head over to the result. That means the third step, the final third step. So in essence, the application now built with the learnings and possibilities we have from Dapper. That means we have only by utilizing the Dapper world to build our application, more simple and leaner architecture or design, because we have a high level of abstraction that just comes with it. Also, it's just by kind of letting it talk through the sidecar, integrated into a resilient distributed system. We can leverage that to build distributed systems. And then we have pluggable components. If you might remember from the beginning, that was one of the requirements also to have on top of the core a pluggable component. And it's deployable in any infrastructure. So in essence, this would be an example of a Dapperized application here. On the right side, we have the core. That's, again, just to recap a little bit, the actual translational part of this application, which turns one data type of payload into another one, and it talks over the queue. with different things. And I have two different examples here listed. For once, we can have like a facade to talk about to accept native API calls from maybe Fire or something, and then translate that back. But we can also build something else, and it's just pluggable because everything is abstracted, right? And then we can utilize even more of the capabilities. The second example shows that it's not just one thing. We can also make an outside trigger or do even more. For instance, from an Azure input event hub as in Dapper input binding. Yeah, well, okay. So now this is finally the result. And with that, I'm done. And I hope you liked what you learned about Dapper, that made you have interest in that topic, and kindly would urge you to check out the website at least, because again, it's very good documented and covers some topics way better than I did right now, I guess. And get in touch with me if you want to talk more about those things. Also, don't forget about the healthcare stuff from the beginning. So if you're interested in that, please get in touch with me. And yeah, thanks for joining my talk.